Hello, this is John from caveofprogramming.com. In this tutorial we're going to implement our own complex number class in C++. Now there's already a complex number class in C++, but I'm going to roll my own here so that we can use it for overloading operators, because the test class that we've been working with, which has an ID and a name, doesn't really lend itself in an obvious way to overloading, for example, the plus operator. So I'm going to implement a class where there's an obvious meaning for the plus operator. You don't have to understand complex numbers to follow this bit of the tutorial. If you want, it's not necessary, but I've created a PDF file that presents an overview of complex numbers, which I'm going to attach along with the source code to this course. But that's not necessary. So I'm going to right click here and I'll give you an exercise in just a minute. So let's right click and go to new class. I'm going to put this in the Cave of Programming namespace. I'll tick to say that I want a constructor generated, and I'm going to call this complex with a capital C. So let's click finish. Now complex numbers have a real and imaginary part. Let's put a private section in here, although private is the default for classes anyway. And let's have here double real and double imaginary. Now, without knowing anything about complex numbers, you can already implement, using the stuff that we've seen so far. Excuse me, I've got a bit of a frog in my throat today, but you can already implement the constructor, the copy constructor. You can implement a constructor that accepts a real and imaginary number to initialize these with. You can implement the assignment operator equals and the stream insertion operator so that you can display this. So if you want an exercise, stop the video at this point and have a go at that. And I'm going to just do that in the rest of this tutorial. So we're probably not going to see anything new here, just little twists perhaps on what we've already seen. Okay, so first of all, we need to make the constructor initialize the real and imaginary parts. Let's go to the CPP file here. And let's add into the constructor initialization list. Real is 0 and imaginary is 0. Although these are double values and 0 is an integer, it will be cast to a double and we can use it to initialize doubles. Let's check that this works already. So I'm going to go to the complex number class. Let's create a complex, which I'll call C1. And that's all we can do with it really at the moment, just create it. So I need to include the header here, include complex.h, and I need to say that I'm using namespace Cave of Programming because I put it in that namespace, and this should build without any warnings or errors. So let's try building it and let's look at problems. And we've just got 2 warnings here actually, which are fine. They're just telling me that the imaginary and real fields are not used, so that's true for the moment. Let's go ahead and implement a constructor that takes the double real and double imaginary parts here. Very easy to implement this. So I can just copy the prototype, go to the complex.cpp, paste it in. I need to get rid of that semicolon and put in brackets. I need to say that this is a member function, so it's a method. And I can use the constructor initialization list to initialize the real and imaginary parts here, like that. So again, if I've got that right, if I build this, we shouldn't see any new warnings. And yeah, we've just got the unused field warnings, which is fine, and it builds. Then in our main program, we should be able to initialize this with the values, let's say 2 and 3. So if we run this, it's not going to output anything, but it should build, and there shouldn't be any new warnings. In fact, even the existing warnings have gone away now that we've used those real and imaginary parts. Let's go to complex.h. It would be nice to have a copy constructor. We're going to implement the equals operator, so we should have a copy constructor as well. Let's say complex, and we're going to say const complex reference other. It can be tempting to leave out consts, but don't do it. because it's really important to have them in there. Some things are not going to work properly without const in the right place. So it's really worth putting in the effort to add const wherever it needs to be added. Let's copy that, go to complex.cpp, and we can add in this constructor as well. It's a member, and we need the brackets there, and we can say real equals other.real, imaginary equals other.imaginary. We'll run this as well, so that should run. I should build without any errors and no new warnings. Let's just add that as well to our CPP file. So we could say here complex C2 equals C1. So remember, this is copy initialization. So this should actually run the copy constructor. And if we want to check here, we can include, let's include iostream, and using name space standard. Now, in fact, since we're going to go on to overload the stream insertion operator, we're going to need that in the header. Whoops, didn't want to click that button. Let's get rid of that, cancel that. So I wanted to save it. So let's go to complex.h and just paste this in up here because we're going to need it. And then it's also included, of course, in the CPP file because that includes our header file. So that should work, and we can just put a check in here. We can say cout copy, just to see that running, because it's good to check things as we go along, that they work as we expect. So if I run this now, we see that it is running. It's in fact running when I do this. So I'll take that out again because we don't want it in the final code. So we've got all the constructors that we need. Let's implement the assignment operator. If we implement a copy constructor, we should implement the assignment operator as well. Now, there are several ways we could do this. We could implement it as a in fact, come to think of it, no, I'm wrong there. I'm getting ahead of myself. There's only really one way we can implement this. The assignment operator has to be a non-static member function. So let's go ahead and do that. So we can say here, remember to enable the chaining of assignment operators, it has to return a complex reference. And in fact, that's going to be a const complex reference because we don't want people changing this actual number here, which we're calling the equals operator on via the reference that it returns. So have I got this right? So when we do the assignment, we're going to actually change these values, and we're going to return a const reference to this object so that we can enable chaining. But obviously, we don't want people changing this via the reference, so we make it const. Then it's going to be operator equals, and we want to say const complex reference other, and this whole method isn't const because it does have to change these values. Let's copy this now and go to complex.cpp. Let's paste it in somewhere here. So again, this is a member function, so I have to put the complex : after this reference because the return type is const complex reference. Let's put the brackets in, and we can say real equals other.real, imaginary equals other.imaginary, and we need to return this to enable chaining here. So we're returning a reference to this object because we specified that it's going to be returned as a reference here. If we build this project, we shouldn't see any new warnings. Let's also check that it does work. Let's say here C2 equals, or maybe C1 equals C2. It doesn't really matter. So when we do that, this is going to invoke the assignment operator. Let's go to build project and run it. And we shouldn't see any new warnings there. It should all be fine. If you see warnings, it's important to deal with them. Okay, so let's let's also operate this. Let's also implement the stream insertion operator finally. Now this we do have several. Well, we have two choices basically. One is that we could make it a friend function so that it can access these, but we could implement it without even making it a friend function, so make it even more encapsulated if we provide these with get methods. The downside there, of course, is we have the get methods, which doesn't break encapsulation, but it's on its way to it. It kind of implies that these values exist. So it's best not to have get methods if you can avoid it. Only have them if you need them. But it's either that or make the stream insertion operator a friend function. So let's go for the latter option. So I'm going to implement here double get real. And I'll implement this here in line because it's just really a small amount of code. And we'll also have double get imaginary. And let's say return imaginary. Let's just format that with the auto formatter. Then let's put the prototype of the stream insertion operator in here. So this is a freestanding function. We're not going to put it within the brackets of the class. We're going to put it outside those. I'll put it after those, or you could put it. Yeah, it should be after. And then we could put the implementation in the CPP file. So let's implement this. So let's say it's going to return a reference to an OSStream reference. The first argument of this is going to be a OSStream reference, which we'll call out. We need to give it a name, of course. That would help. So it's going to be operator. And left bit shift operator, or in other words, a stream insertion operator. And the second argument that we pass to it, as we've seen before, is going to be our class that we want to output. So it's going to be a const complex reference. Let's just call this C. So I wouldn't normally give things single letter variable names, but because this is going to be just a really short function, it's going to be clear what C is, then I will do here. So we can't declare this const because it's not a method, so it can't change these values here. This is just a function. Okay, so let's copy this. We can't put const there, in other words. So let's go to complex.cpp, and I'll put the functions that I implement at the top of the file here, just so we can easily spot them. And to implement this, we just need to output the complex number in some meaningful way. So I'll take an easy option and implement it as a pair of numbers, real and imaginary, separated by a comma and surrounded by brackets. Let's put a bracket in there, and then we need c.getReal. Let's have a comma like this, and c.getImaginary. And let's have a closing bracket, and then we need to return out. I think that looks good. We've got a warning here saying getReal could not be resolved, but let's take a look here. So we've got these getReal and getImaginary methods. So it seems like it should work, unless there's something I've forgotten, which is very possible. But let's run this and see. So we're getting well, I've done something really stupid and I'm not completely sure what it is. So we've got getReal, getImaginary. They are public functions, and it says here function is not marked const. You know, this is something that I actually wanted to make this mistake deliberately to show you this, but I thought I got a completely different mistake which flummoxed me. But yeah, this is something that I actually did want to show you. So the problem here is that this is marked as const, but we're calling methods on it that could, for all C++ knows, could change that actual object. So it doesn't know if getReal, for example, changes C or not, and yet we've said that it's const, so it won't let us call it. And the solution to that is to go to complex.h and declare these methods as const, so that we're guaranteeing they won't change the object that they're called on, and then we can call them via variables that are declared as const. Let's go to project.buildProject now. And this looks good. Let's check the warnings, the problems. There's no warnings there, so hopefully it's good. Now we should be able to use all these methods. Let's check this. Let's say cout. Let's do C1 and see how that looks. So if we run this now, we've got our complex number, and C1, well, let's try C2 as well. So if we run this, this also works. It's equivalent, it's the same as C1, which we've set in two places. Actually, I'll just create a, let's maybe have a let's have a complex C3 here, which equals C2. And we should be able to we should be able to chain this operator. We should be able to say C3 here as well. Maybe have some space in between this, like this. No reason why we can't put strings in there as well. Let's run this. And some horrific error there, just because I've got a gap in the operator. Okay, bear with me, I think we're getting there now. Let's build this and run it. And so yeah, we've got two identical complex numbers here. One is assigned by copy initialization, but let's make it explicit that it's using the copy constructor, just to test the copy constructor. And this is actually also using the copy constructor, but what we can do is make this use the assignment operator. Let's say C3 equals C2. We should be able to do all these things interchangeably, just as we feel. Okay, so that's it for this tutorial. We got there in the end. In the next tutorial, we're going to look at overloading the plus operator, and we're going to look at several different possibilities for that. So it's worth having a go at this if you haven't already. We're just building on stuff we've seen so far, and we'll take a look at the plus operator in the next tutorial. So until next time, happy coding.